Hey Becca, what are we learning today?
Today, we're going to take derivatives using the power rule. Here's the general formula for a variable x being raised to some real number power a. Now, if we were going to take the derivative of this function with respect to x, there's a method called the power rule. You take this exponent, a, and you bring it out front, and you multiply it by the x, and then the exponent is decreased by 1. So the exponent becomes a minus 1. You bring the power down, multiply it by the original x, and raise it to the a minus 1. Let's try an example. F of x equals x to the 4th power. And we're asked to find the derivative of this function with respect to x. We bring the 4 down in front. We multiply it by x raised to the 4 minus 1. This becomes 4x, and 4 minus 1 is 3. So the derivative of x to the 4th is just 4x to the 3rd. I placed the formula on the top of the screen for reference. Here's another example. F of x equals 5x to the 3rd. We're going to follow the same rule. We bring the exponent down, the derivative equals, bring the exponent down in front. The 3 comes down in front. Now we have a 5 in front of this x. The 5 is going to stay there. And then our exponent becomes 3, decrease it by 1. And this equals 3 times 5. We can combine these terms because it's just multiplication. 3 times 5 is 15. X raised to the 3 minus 1, 2. 15x squared. Here's another example. F of x equals 2x plus 3x to the negative 3. Now, this x does not have an exponent. What is its exponent? It's just 1. That 1 is kind of invisible, but I'm going to put it there for reference. Now, when we're finding the derivative of this function, we're going to use the power rule, and the 1 is going to be important. The power rule says bring this exponent in front and multiply it by whatever was there originally, and then we take the power and we decrease it by 1. So we need to know what that exponent is so that we can know what to decrease it to. Plus, let's do the same thing with this one. I made it more tricky because it has a negative power, but it's going to be done the exact same way. Bring the power in front, negative 3 comes down, times whatever was there originally, 3x, and then this power, negative 3, gets decreased by 1. Let's reduce this a little bit. 1 times 2 is just 2. X to the 1 minus 1 is just x to the 0. What is anything to the 0 power? It's just 1. So we're only left with the 2 here. Notice that if you have a constant in front of an x and it's raised to the first power, then its derivative is just the constant that's in front. That's important because this comes up very frequently. Plus, negative 3 times 3 is just negative 9x raised to the negative 3 minus 1, which is just negative 4. Here's an example of a simple quadratic equation that we're going to take the derivative of. 5x squared minus 2x plus 1. Now we have that invisible 1 on the x here. We don't have any x's here. We're going to put an invisible x to the 0 power because x to the 0 power is simply 1. So that doesn't change our equation. Now let's use the power rule to find the derivative. Bring the power in front, 2 times original 5x raised to the 2 minus 1 minus, we did this one already, but I'll go through it again. Bring the power in front, 1 times 2, x raised to the 1 minus 1, plus, we're going to do the same power rule for this one, even though it has a 0 as the power. Bring the 0 out in front, times 1 x to the 0 minus 1. Let's reduce this a bit. 2 times 5 is just 10. X raised to the 2 minus 1 power is just x raised to the first, and I'm just going to leave it as x minus. Remember what we did here. 1 times 2 is just 2, and this is x to the 0 power, which just becomes 1. So we're only left with 2, the coefficient of the original. And then in this term, whatever this is being multiplied by 0. What's 0 times anything? It's just 0, so this term completely cancels. Notice that if you have just a constant number right here, remember we put this x to the 0 in there as a placeholder, but we started with just a constant 1. If you're taking the derivative of a constant, the derivative of that is just 0. So we went from a quadratic equation to a linear equation. The derivative of a quadratic will give you a linear equation, 10x minus 2. Here's an example where x is being raised to a fractional exponent. This is done the exact same way as all of the others before. When you're finding the derivative of the function, we bring the power in front. Remember to carry the negative. Negative 1/2 times 13x. Now we need to decrease this exponent by 1. Negative 1/2 times 13, I'm just going to write that as negative 13 over 2. What is negative 1/2 minus 1? Negative 1/2 minus 1 over 1, common denominator, this becomes 2 over 2. Subtract the tops, negative 3 divided by 2. So negative 1/2 minus 1 is just negative 3/2. So now this x is being raised to the negative 3/2 power. And I know that this equation looks a little bit funky, but it is still the derivative of the original function. Here's our last example. F of x equals 5x to the 7/5 power. Let's do this one just like we did all the others before. F prime of x equals, bring the power in front, 7 over 5 times original 5x raised to the 7/5 minus 1. What is 7/5 minus 1? I'm going to change 1 to 5 over 5 so that we have our common denominator. Subtract the tops, 2, leave the bottom the same, 5. So 7/5 minus 1 is just 2/5. Let's reduce this a little bit. 7/5 times 5, the 5 in the denominator and the 5 in the numerator will cancel. We're just left with the 7. X is raised to the 2/5 power. I'm hoping that you're feeling very powerful now that you know how to use the power rule. If you thought this video was helpful, you should give it a like and comment if you have any questions. And remember to stay tuned every Monday and Thursday for new videos. You should subscribe so you don't miss any. See ya!